Okay, hello folks. This is a follow-up to the video segment that I posted yesterday, and it's a cylindrical, very simple cylindrical pressure vessel. And the one that I posted already, the ends are not capped, okay? And I apply the load that is coming from end pressure as a distributed as a edge load on the cylinder, as you see. Here, I want to repeat that same problem, except that the ends are going to be capped, and we'll see what the difference is with the results that we got. Here's my geometry, same geometry that I had before. It's three plies on the or laminas on the cylindrical surface, and on the sides though, on the sides you have only two plies, 15 and minus 15. The thickness of the 15 and minus 15 degree plies are uh, 0.05, and the one for the 90-degree ply is 0.15. It's made of carbon epoxy. And because of the nature of the stacking sequence and the geometry and the load, there are planes of symmetry involved here, but I'm not going to do that. I will model the entire cylinder as it is. My strategy is going to be like so. First of all, it's a cylindrical surface. However, what I'm going to do, as in the previous video segment, and I urge you to see that if you want to have a better idea what's going on, as basically four pieces. The top with its own rosette, the bottom with its own rosette, and the front and the back, incidentally, they can use the same rosette, and it's drawn here, okay? If you wanted to do this thing as a single surface, the issue is going to be compounded, and in Catia at least, I'm not going to do that. Once again, there are planes of symmetry here, and in this particular case, 1/8 of the cylinder may be modeled, but I'm not going to use that. Now, this is what I did in the other video segment, okay? So the ends are not modeled. It's just that the effect of the end is modeled as a edge load on this side and on that side, okay, 3000. But that is not what I'm going to do here. Instead, I'm going to model the entire cylinder. The material properties are taken to be from carbon epoxy, and they're coming from that website. And the analytical solution also is coming from that same website, and we're going to compare it with that. Okay, so let me see. So we're going to be comparing our results with these things that we already got from hand calculation in that website. I'm not using the strength properties here because we're just looking at the stress calculated stresses. Okay, so I'll minimize this or keep it handy because occasionally go back to it. Oh, let me show you something here first of all. In the other video segment, the one before this, I think it was video 12. What? Just bear with me for a second. I already created my material, and if you look at it, there's actually two. This is done in the first 5 minutes of the previous video segment. One of them is called carbon epoxy 0.05 inch. The other one is carbon epoxy 0.15, because the difference between these two, the materials are the same, the properties are the same, except for the cued thickness. So for the curved surface, or 15 and minus 15 degrees, I'm going to be using this cued thickness, and for the 90-degree ply, I'm going to be using the cued thickness of 0.15. So we'll not do this thing. It's already done and saved. You can look at it yourself if you want. Okay, so let's start. On the top surface, on the YZ surface, I'm going to sketch. We have to be in the right workbench though. Shape, generative shape design. Okay, so on that, I'm going to draw a semicircle. and I think the diameter was 12, so the radius is 6. So this is going to be 6 inches. Okay, and exit and extrude it symmetrically, 20 inches in each direction. So this is going to be basically the top. I'm going to join it and double click on join, flip the arrow so that the direction of the joint surface is inward. When I create my meshed elements on the surface, the normal to the shell element is going to be in the opposite direction, so it's going to be up. Okay, let's see what we got here. I'm going to extract the boundary of this joint surface. So you go here under the boundary, see that boundary? You select the surface, and it's going to be this boundary. For bookkeeping purposes, I'm going to change all of these things to their proper name. So I'm going to make this thing top. Make this thing top. Top. And finally, the boundary is going to be called top. Properties, top. Okay, while I'm here, I'm going to create the rosette coordinate system for the top piece, which is going to be like that. Now, it says here cylindrical transfer type, but because, and when I was using R21 to do the drive shaft problem, there is the option of cylindrical, but just ignore it. So let me actually change this thing to well, Cartesian. How about that? Cartesian, both of them. Cartesian. I'm not going to use a cylindrical type. And same thing with here. So Cartesian. Cartesian. Okay. So let me go ahead and create a axis system. So where is this thing for axis system? Oh, it's right here. See that? Axis system. I will move it up so that it's not all cluttered here. So I'm going to move this thing up. And the only thing is that your Z is going to be maybe 8, 9. Let me make it 12. Right, so it's going to be the Cartesian coordinate system is going to be up there. And okay, so notice that it puts the default thing here, and this is consistent, X, Z up, X coming towards me. Yep, that looks good. And let me uncheck this current so that the global coordinate system is always current, okay? All right, so while I'm at it, I'm going to change this thing to be top. Very good. Now we're going to do the bottom portion. So on that same vertical plane, YZ plane, I'm going to sketch. Then we will draw a circle. It's possible to mirror this thing and use it, but I rather do it the long way. Oops. Okay. First of all, I noticed that accidentally this point is not on that axis. So I select that point, control this, and I'm going to make it coincident. Should shift it down. Very good. And dimension it. Dimension this semicircle to be 6 inches. Exit. Okay, there you are. Extrude it 20 inches, just like before. So this was mirror extend. Okay. Very good. And join it. Join the bottom one. Oops. So, let me try it again. Join the bottom surface. Say OK. Double click on it to flip the arrow upward. Make sure that this will ensure that the normal to shell element is going to be pointing outside of the cylinder, and get the boundary of this surface right there. And then I'm going to rename these things to be the bottom, properties, bottom, 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 and finally, oh, this point, I'm sorry, this point, let me, this, I didn't mean to change the name of that point. Properties, bottom, and the boundary bottom, bottom. I accidentally changed the name of this point, which was point one, I believe. I'm going to rename this thing to be, although it's not important, we're never going to be using this again, but I'm going to call it, I'll still call it top, because this was the point that I created to create the top rosette. Okay, fine. We're never going to be using that again. Now, while we are at it, we're going to create our coordinate system. So create a coordinate system, create a point. The only thing is that I'm going to put a minus 12 here, so that the point is going to be created down below, right? And okay, so now we're going to, in order for it to look like this, I have to flip Z down and X going away from the screen. So we're going to rotate this thing. You put the cursor around the Y, in the Y box, right click rotation. Let's see now, if I rotate it by 180 degrees, it'll do the job. 180 about the Y axis. Notice that Z is down, X is in the opposite direction, and it's okay. This one, again, to be consistent with what I did up here, I'm going to change that thing to bottom. I will never use that point. Okay, very good. First of all, we save everything. Now we're going to do now we're going to go to the front and the back, okay? So the front and the back, so let's go ahead and do that. We can go and extract that and these two edges. So let me go ahead and yeah. Okay, so there are different ways of doing it. So let me hide this bottom at the top. Let me hide this thing for now, and the bottom. Let me hide it. Okay, so we're gonna go and do a um, how about one way of doing it is to extract. So we go here, not there, where the boundary is, right there. See extract, extract. Move this thing out of the way. Okay, so multiple extract. So we do this and that, and we say okay. And I'm going to call this thing to be properties front. There are different ways of doing this part of the problem. Okay, and then I'm going to fill this front surface. I don't know whether I have to join it or not, probably not. So let's see now, where is the fill? Fill is, you see right there, fill, front, takes the whole thing. There we are, okay? So why don't we call the name of this thing also to be front, properties, front, okay? Let's create a coordinate system for it, axis system. Let me move this location a bit in the x direction. So create a point. Okay, so we want x is y is 0, z is 0, and we want this thing to be, I don't know, maybe 30. preview. So it's going to create at that location. Fine. And there we go. This is good. X coming towards me, Z doesn't matter, up, etc. Okay, so we call this thing front and the back. Oh, but this is good. This rosette is going to be first of all, this is the point that I created. So as I said, I'm never going to be using it. Front. Okay. The coordinate system that we created is up here. Okay, so this top one, I forgot to rename it. We're going to make it the bottom. That was the top one that I already did. And this is the one that I just created. Properties, I'll call it front and back. About front and the back. Okay, good. Incidentally, now I have to again extract these two and make a surface there. You may not even need to extract it, but since to be consistent with this you really don't need to extract these things. You can put a boundary between these two, but to be consistent with what I've done, I'm going to extract it. This step is unnecessary, okay? And I really did not have to use it in the first instant either. So there, you say okay, and then fill. This is the thing that I want to fill. There we are. So I'm going to call this thing back, properties, back, and back. Okay. There are other ways of creating this geometry with the exact things that I had in mind. I don't need a coordinate system because that uses the same coordinate system that we have here, front and the back. Okay, save everything. As far as the model is concerned, we're all done. So we're going to go to Composite Design. Composite Design. Parameters, right here, create parameters. Add the material. Material library, place that I created and stored them. So it was on desktop, PV, capped. This step I didn't do, it was done in the previous video segment. So we add this and another one. This is the other acute thickness, 0.15. So right here. Now as far as the rosette is concerned, add a rosette. Let's go ahead and create the one from the top coordinate system. Just notice something here. Okay, and we're going to use Cartesian. Remember, I I said cylindrical, then I corrected it. Okay, another one. Uh, Bottom one, and add the last one. And I don't think I need anything here. But the directions, oh yeah, direction 15 and minus 15. So we don't have the default directions are here. So we say plus 15, plus 15. Put a 15 here. And let's change the color to be brownish. Add minus 15, minus 15. Put a minus 15 here. Dark brown. And I think we have done all of these. If you like, you can call your rosettes front up, down. Let me actually do that here. Properties. I could have called it exactly what I wanted in the at the step before this. So I'll call it top. A lot of these are unnecessary, but I want to be consistent. Properties, bottom. And this one is going to be top and bottom. Top and bottom. Bottom. Okay, save everything. Hide these rosettes. Hide. Hide. And hide. Okay, so we are good as far as this step is concerned. Now we're going to create our plies. So I'm going to do it the long way, the inefficient way, manual plies. So we're going to create a ply group, call it top. For the surface is the top surface. The direction, I'm going to flip the draping direction upward. Okay, rosette is going to be top one, and lock the ply draping direction. So that's good. So we created our top one. We can do the plies now, or we can do all these ply groups first and then do the plies one by one. So you know what? Let me do it. Let me do it now. So click on it, ply. Where do you want to put it? In the top ply. The boundary or the curve or the contour is that top boundary that are extracted right there, or not the bottom one. Top one. Notice it did complain. And carbon epoxy, that's not the right one. 0.05 cured thickness and 15 degrees, plus 15 degrees. Okay. Another one, same ply group. Boundary is that top boundary. Attribute is minus 15. And last ply in that group, curve boundary is the top. Attribute, this is one step, this is 90 degrees. However, I made a mistake in the other video segment, the earlier one. I forgot to change this to the cured thickness of 0.15. Remember, 90 degrees goes with cured thickness of 0.15. So I ended up correcting it and took some time. Okay, so that's good. You can always check, make sure this is right. So if you do the ply exploder, top, apply. So we have 15 minus 15 and 90, cancel. Let's do the same thing for the bottom. So first ply group, bottom surface, plying direction, draping direction, you reverse it. Rosette is the bottom one. Lock the, and name of this, change it to bottom. Now manually in there. Okay, so let's go to the geometry. For the geometry, bottom curve. There are much faster ways of doing this. Change the cured thickness to 0.05, 15 plus 15. The other one, same ply group, bottom, curve, bottom curve, minus 15. And finally, for the bottom ply group, curve, bottom curve, attributes, change, make sure you change the material to the one that says 0.15 inch, and this is going to be 90. Okay, you can always check both of these at the same time, this and that, and apply. They should look exactly the same. Okay, so cancel. Okay, so now do the front and the back. How about clicking here, ply group. I will do I just noticed something. There is a mistake that I made here. If you look at that, the direction of the Z must be perpendicular to the surface. And when I created my coordinate system, I forgot to do that. So we're going to make sure that this is correct. So double click on this coordinate system. Okay. And then we're going to rotate this thing by, how did I want it to be here? We can rotate it first about Y. The only thing we have to make sure is that Z is perpendicular to that, okay? But I will be consistent with this thing that I did there, okay? So first of all, we rotate this thing about the Y-axis by 90 degrees. By 90 degrees, rotate by about the Y-axis by 90. Notice that this is okay, and rotate it. If you wanted to make it look like that, you now have rotate about Z by 180 degrees, and rotate by Z 180 degrees. Is it 180? 90 degrees. As a matter of fact, by minus. Uh, Using the right hand rule, no, I think 90 degrees is good. Rotate by 90. You can always fix it if it doesn't look right. Yeah, that's good. That looks exactly like what I have here. Very good. And you say, okay, we're going to go back to, we're going to go and create a ply group. So front, I can do them at the same time, but I will choose not to do that. Front. So this is the surface. Draping direction is correct, outward, and rosette is front and top. Oops, that was a mistake. That was I should have called it front and the back, not top and the bottom. But that's okay. I said top and the bottom. Say okay. But let me go and fix this name. This was a bad name that I did. This was front and the back. Oh, okay. I must have done it here. This is the one that I mistakenly called top and the bottom. This should have been front and the back. Properties, front and back. Okay. What I did would have worked, except that it was a bad name. That's pretty much it. So this is the front. So let's add the Plies to it. Over here, a curve. Remember I extracted those two front. This is the one. Yeah, I can use this, or I could have got the boundary of that. Either way, this is going to do front. Okay. 0.05, because there's only 15 and minus 15 degree Plies there. So plus 15. Let's click the correct rosette. Again, another one in there. For the curve, I will use that extracted surface, extracted edges, right? That's the right one. And minus 15. Okay, very good. And let's do the back one. I decided to do these separately, but it was not necessary, so I'll call it back. Okay, the surface is the one on the back here, the surface, and dripping direction outward to be just like the other surface. Okay, very good. Rosette, front and the back, and lock the ply directions. Okay, very good. And let's create them. So ply, you can see that this is not a very efficient way of doing this. So we go back, attributes, plus 15. Okay, last one in there for curve back and minus 15. This is not a practical way of doing problem. We have a large number of plies, etc. We have talked about these things in the first couple of video segments. You can, in Catia, at least one way of doing that is you can do copy and paste of the plies, or you can export the stacking sequence and change it, and then reading back into Catia, etc. So let's save everything. We're pretty much done here. So now we're going to go to advanced meshing tools. Okay, so say okay. Let's mesh the top one. Surface mesher, top one. 1 inch parabolic quad only. You have to make sure that you capture the meshes which are very close to each other. So that's what this thing does. You say okay and mesh it. There we are. I'm going to change the name of this thing to be top. Okay, and do it again. Do it again for the bottom. Same information. Mesh it. Okay. Exit. To the front. This one. Oh, I just noticed that when it meshes it, the direction of the normal is going to be outward. See that in the inward direction. So this was what I should have done. Unfortunately, there's not much that can be done here, uh, and it doesn't matter for this problem. But what I should have done is to uh, join this surface. Remember this surface that I extracted the edges and then filled it, right? Fill. I should have joined the fill and then make sure that the direction of the arrow of that join is outward. It doesn't matter in this problem, but in some problems it could be an issue, because we can fix it here by a trick, and I'll show you what's happening when I put pressure on these surfaces. For the for the top and the bottom, they look correct, but for the sides, I have to change it from positive to negative or negative to positive to make sure that it actually pressurizes outward. So that's why. I don't want to go and repeat that. So, okay, I'll show you what I mean later. So exit. Let's do the end. There we are. Same information, same problem. Zap it, mesh it, exit. You'll see. Okay, so this is all done. Save. Oh, analysis. Save the analysis file. File, save management. The analysis, we're going to save as analysis 1 in the right folder. That is the right folder. We say OK. So now when we go to generative structure analysis, there we are. If you say show me the elements, mesh visualization, looks good. However, because of what I said, the normal to these elements on the ends is going to be inward. The normal to the side is going to be outward, which is okay, but that means you have to see that you have to change the sign of the pressure for the ends. Let me give these things name. Properties, top, bottom, BOT, front, front, properties, back. Okay. Let us deactivate this. Deactivate that and apply our pressures. Okay, so let's see now. Where is the pressure? Right there. Notice that when I select the top and the bottom, the directions are with a minus sign, they're outward, exactly what I want. Okay. But when I select the side with that same minus sign, I bet it's going to be inward. So how do we get to see that? Let me change the rendering here to, yeah, you see that? Where's the pressure? These pressures, you see that? They're, they are inward. And the reason is that the fact that the normal was not pointing in. So what I'm going to do is I'm going to cancel that. Here's what we're going to do. So let's try it again. Pressure on this and that, minus 1000. Fine. Pressure on the front and on the back, I'm going to make it plus. Okay. So if you change this thing to wireframe rendering, you can see that they're all pressurized outward. Okay, see that? Outward. Okay, outward, 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 and the same thing over there. Had I fixed that by going and changing the direction of join that surface and flipping the direction, they would have looked a lot nicer, and I could have done all four of them at the same time. But that's life. Okay. Notice that these arrows, red arrows that you can see here, you can see it at the ends. That has to do with the direction of the join, and I didn't join it here. Okay, good. So now we're going to impose the material. Well, actually, let's apply the isostatic restraint here, because this structure is going to be moving on the rigid body. We have to use the 1, 2, 3 rule or ask Catia to do it automatically for us. That's this isotropic restraint. It's going to put 4 on all these 4 pieces. I don't have to select anything. And finally, import material properties. So let's see now. Where is the import? Go to 2D property right there. So import composite property. Okay, it says what is the surface? Support is top face. You have to do this separately. And ply by ply, and you have to go and select ply group 1, which is the top one. Top one. Say okay. Say okay. Repeat that. Bottom surface. By ply. Bottom ply. Okay, make sure symmetry is checked. That means it's symmetrically placed about the reference surface. Do another one. Let's do the front face. Y ply. Front. And let's do another one for the back. So turn it around. Back. Y ply. Back ply. Say okay. And make sure you save it. And now we're going to run it. Before I do that though, I want to make sure the direction of my composite plies are the way they're supposed to be. So let's run it, but not the whole thing. I'm going to do the mesh first. Okay, now you can go to properties, put the cursor on it. Remember, you can call this thing top, bottom, front, and the back, but I didn't do that. Okay, so generate image, composite angle, and make sure that the height is on. This thing is on. The part is showing. My point is this. These must be parallel. If they're coming at, not parallel to each other, you have not done it properly. And please check the video segment on drive shaft, and it has more information on it. Over here, it really doesn't matter. Over here, it doesn't matter. Now you can go to the other ply. Let's go to the other ply here. Where is this thing that I created? Right there. Double click. More. Go to the second lamina. It shows you these things. See the first one? See, change the direction. They must be parallel to each other, and they are. And if you go to the third one, of course, the ends don't have anything, but here you have 90 degrees. Okay. Okay, very good. Now we can go and run it. Run it, but make sure it's not mesh anymore. It's all. So it's going to do the calculation. Say okay. Done. Let's look at the deformation. Looks good. Change the thing to average ISO. Change the rendering to material shading. This is what I expect. Okay, the ends will bulge out. Now look, that pressure would have been extremely high for for the kind of ends that I have, but we're not checking accuracy on me, you know, whether it's meaningful or not. 49 inches, the whole thing was 40 inches. The ends are going to bulge out 49 inches. But the ends are not important to us. And as a matter of fact, having two layers of 0.1 inch under 1000 psi, that doesn't surprise me. Okay. Now let me do something here, and if you just concentrate on the surface here, okay? And we talked about how to do this. So for example, you can go and say, create a box group. This box group, you just concentrate on this piece. Okay, so let's go ahead and plot the stresses. So we go here, right click, generate image, stress, and let's do uh, doesn't matter really. Okay, so if we double click on this and say show me the meso stress, okay, and show me only the box group, so we go on the selection. So let me uncheck this box. Go to the selection, show just the box group right there. Okay, so let me hide this. Okay, so this is the meso stress. Let me see for a second. Let's look at the layer uh, discontinuous first of all, and uh, layer 3 is the one for 90 degrees. And look at what you're getting here, roughly 3 point something. It's in this range, in the range of 3.3, 3.4. And if you look at the result, it's right there. Okay, I do suggest that you actually look at these things carefully. So we'll say this thing is okay. This was layer 3, right? So let me do another one for you. Generate image, stress. Okay, nodal component. Double click on this and say show me the principal values. Principal values. What did I do here? Material shading. Wait a minute, why is this thing not showing? Oh, here, because I accidentally hit this thing. Right click, hide and show. Okay, and show me the stuff in the box only. Which one is this? Principal values. Okay, so you can see that these numbers, is this the one? Principal, stress tensor, nodal values. These are the ones that need to be compared with, that was layer 3, right? It was layer 3. I'm pretty sure this was layer 3. Let me see. Oh no, layer 1. Okay, what is layer 3? If you look at layer 3, almost 30. Yeah, so these need to be compared with that value. Okay, so let me see the other one, C22, and this is roughly 2000. You can see that 2000. See this 2000, and those are the ones that are going to be compared with this value. Yeah, the bottom line is that this is going to be fine, except that when I did it earlier with the edge load instead of the ends being modeled, I think the results match the theory. Match theory means these results more closely, because these assume exactly that kind of a loading. Okay, so that's pretty much it. We have done a pressure vessel problem, doing it two different ways. I've done a drive shaft problem, and we're going to move on. Have fun.